Toolman and Sean. Today, what we're going to show you how to do is adjust the throttle position sensor on your 22RE motor. We're doing this as part of the motor swap that we did at Yoda One Performance in Riverbank, California on my 85 4Runner. Nick, the owner of Yoda One, highly recommends as part of an engine swap that you test and adjust the throttle position sensor if it needs it. So we're going to utilize Mike, who is one of Nick's employees at Yoda One, and he's going to show you how to test the throttle position sensor and adjust it on the motor. And then we're going to show with a little more detail with doing the testing and adjustment on the bench. We wanted to show you both ways because it is going to be easier to make the adjustment with the throttle body off, but it requires you to disassemble a few more things like pulling off the coolant hoses that run through the throttle body to keep it nice and warm and cozy. Without further ado, let's get started with showing you how to test and adjust your throttle position sensor on your 22RE motor. We've got the new 22RE motor in. It's running well, but one thing that Mike wants to do before I drive home to San Jose is he wants to make sure that the throttle position sensor is in the correct range, and if it isn't, he's going to show you how you can adjust it to get it back in the correct range. So here we go.
Step one will of course be to remove the connector on the throttle position sensor, either with a pick or a nice little flathead screwdriver. Hit the little tab on one end and hold it, slightly pulling on the connector. We can actually separate it just a hair to keep the lock in place, and then on the other side picking up on that clip and pulling off the connector. If things are broken, typically there are pigtails you can buy online to replace them and get them to connect properly. When I test the TPS, there's a total of 5 steps typically that you find, and I get away with doing just the first 3 steps because typically the problem is within those first 3 steps. The other 2 steps include a wide open throttle and not really any kind of specification for throttle position, but I feel half throttle and wide open throttle are the same in a 22RE. So the first 3 tests are the most important to find out if your throttle position sensor is working or not. The 22RE throttle position sensor has 4 terminals: VCC, VTA, IDL, and E2 from top to bottom accordingly. On the first step, we are going to hook up to the VTA and E2 terminals. So from the top, that would actually be the second one down and the very bottom terminal. Alligator clips or custom terminals like I've made here will help the testing greatly. You want to make sure you have a good connection on these terminals and they aren't touching anything other than the terminal you want to test. So the bottom terminal and the second from the top, making sure you have good connections in there and it's not going to come loose or touch another terminal that you do not wish to test. Once you get hooked up properly and you feel like you got a good connection, go ahead and take your leads from your voltmeter. Anything that can test resistance is all you need. Here we have a generic meter. It does have a resistance scale that we can click onto. And in this year, in 1985, the spec range for this is between 200 ohms and 800 ohms. Being that this is the first test with no feeler gauge installed in between the throttle stop screw and the throttle linkage, this test appears to be within range.
So we're at 554 ohms resistance right now.
Correct, which is right in the Goldilocks range. If your TPS is not within range on this first step, stop immediately and adjust your throttle position sensor. In step 2, you're going to move one lead down one terminal. You're going to leave the bottom terminal on the E2 alone, but jumpering down one terminal to the IDL terminal for the second step. You're also going to use a feeler gauge of 0.0224 inches or 0.57 millimeters to be able to put in between your throttle linkage and the stop screw. The idle stop screw is down here underneath your throttle linkage, and you'll see there's an adjustment screw down here with a little 8mm nut on the other end of it. And you want to put the feeler gauge in between this little metal tab of the throttle linkage and the idle stop screw. So within this step 2, you're going to take a feeler gauge and gently open up the throttle plate just slightly, making sure that your feeler gauge is not being bound up or twisted in this area by some other component or item. Making sure that you have a good feeler gauge thickness worth within that stop screw and the throttle linkage. With our feeler gauge inserted between the throttle stop screw and the throttle linkage, we can see here with our leads hooked up correctly on the right terminals, the meter actually shows an OL reading, which means wide open or out of limit, which is incorrect for a reading we want on a step 2. In step 2, the specifications are less than 2,300 ohms or 2.3 kilo ohms. In this case, with a wide open reading, it is beyond that less than 2,300 ohms. This is a need for adjustment. In step 3, you're going to use the 0.0335, or in my case, I have a 0.032, which would work just fine, to use that feeler gauge within the throttle stop screw and the throttle linkage, just like the 0.0224 feeler gauge was inserted in the same spot. So just as in step 2, we're making sure that our feeler gauge is not being obstructed by twisting or in the wrong location of the idle stop screw and the throttle linkage. Once you have the feeler gauge in place and you feel pretty good with your testing of that feeler gauge in that space, we are going to keep our leads on those 2 terminals we were on previously in step 2, and at this point we should get an OL reading or open.
So a good test 3 is showing that it's wide open?
Right.
So Mike, you're saying that in step 2, if you find that, that's out of spec, but in step 3, you are looking for that fully open throttle.
Correct. What it is mostly a switch at this point in step 3. With the 0.0335 feeler gauge installed, the TPS has hit a point that tells the computer that it's beyond a certain point in order for it to regulate the fuel control properly. If your throttle position sensor needs adjustment, there are 2 set screws on each ear, one on top, pretty easy to access. The one that's a little bit more difficult is 180 degrees off that, down up underneath, typically very difficult to reach, and being a Phillips head is almost impossible to reach with the throttle body attached to your engine. In order to be able to take that throttle position sensor and adjust it, you will typically need to remove the throttle body. When removing the throttle body, we're going to try and take off as little as possible. So 1, we don't open the cooling system up and have to re-burp the cooling system. And so we're going to try and cheat our way through these coolant hoses that are attached to the throttle body. And just being very careful, we're going to try and remove the throttle body and get it to where we can access the screws for the throttle position sensor.
So Mike is just removing the front air tube, just a couple simple clamps with a 10mm bolt. Removed all those vacuum lines. Just popped off the throttle linkage right there. What is that one right there? Is that just another
This
vacuum?
is the idle air control bypass hose.
Now he's going to remove the 12mm bolts that hold the throttle body to the plenum.
Being very careful to remove the throttle body off of the single stud that this throttle body does have. You're going to try and easily come straight out off that stud and very carefully removing off to the side. Once you do that, your access point to this throttle stop screw will improve very slightly, but it will improve some sort of angle to be able to reach with a Phillips head screwdriver possibly. Toyota uses a Phillips head screw to retain these throttle position sensors, and it's probably not the best design because typically they strip out very easily. If yours has not been tampered with too much, you might have success being able to remove these screws without too much of a headache. Typically, if they are stripped out and you are struggling to get them to work, do not reuse them. I would recommend highly to replace them. just to keep yourself from having problems in the future for whatever reason if you do have to replace the throttle position sensor again in the future. We are going to take advantage of this opportunity with the adjustment of the throttle position sensor to replace our screws with an Allen head, and that makes it a little bit easier maybe if we need to actually go through either a replacement or adjustment in the future without having to remove the throttle body. Very firmly you're going to put the Phillips head screwdriver on these, and without tilting the screwdriver in any specific direction but getting the straightest shot you can at that screw, you're going to put as much tension as you can within that screw so you don't strip it, and breaking them loose. Very carefully, it can be done. We're also going to attempt the lower screw, which is a little bit more harsher angle here. Again, on the bottom screw, you're going to get a straight shot as best you can so you don't strip the screw out, and pressing firmly into the throttle body, you're going to twist your screwdriver and break loose the bottom screw as well. See if I can feel my way in there a little bit.
So he just replaced that Phillips head screw with one of the Allen head screws.
Not necessary, but your best bet to make sure it's serviceable in the future.
This is definitely a smart choice to replace those Phillips head screws and put an Allen one. Allen ones are a lot less likely to strip. You get a much more positive connection with an Allen wrench.
Being careful to not tighten completely, so that way you still have a movable throttle position sensor in motion. You want to get those screws seated to a point so you still have a little bit of play, but the throttle position sensor is firmly in place, still hooked up to your throttle body. When you're adjusting the TPS, I always start at step 1, no matter where your test failed, just to make sure that we can adjust this thing within range. We are on the second terminal down and the very bottom terminal. That would be VTA and E2 terminals for step 1.
Starting from the top with the throttle body in this orientation, the second pin and the fourth pin.
With our meter hooked up and on, we are going to slightly adjust our TPS to see if we can get the optimal reading for at least the stage 1 reading. While you're moving your throttle position sensor, pay very careful attention to your meter so you can see if you're within range on at least your test that you're currently testing with. As I'm moving the throttle position sensor, you can see the meter vary in its reading. It's changing ever so slightly with a fraction of an inch of movement on this throttle position sensor. So the slightest movement will make your adjustment change. That's why it's such a careful adjustment to make sure you're within range. In our step 1, we are looking for 200 to 800 ohms in the 85 through 88 years, and it changes to 470 to 6100 ohms in the 89 through 95 model. This being an 85, we are going through the 200 to 800 range. Once we feel we are in range for our current test, we are going to slightly snug down the screw so that we can lock in our TPS position for the moment. So we're going to take our step 2 feeler gauge of 0.0224 and insert that into our throttle linkage stop screw location. With your feeler gauge in place and no obstructions causing a deflection in that feeler gauge thickness for your throttle stop screw and the throttle linkage, in step 2 we are going to put our terminals back into their location for step 2, which would be the IDL and E2 terminal, the third and fourth terminal from top to bottom. Again, making sure our terminals are not touching. This is where Timmy's throttle position sensor failed a test and showed an open reading on step 2. With our throttle stop screw that is now secured from test 1, we will loosen it up ever so slightly just to release tension enough to adjust the throttle position sensor. We are going to adjust counterclockwise until we start getting a reading on our meter. If for some reason, no matter how far you move your throttle position sensor within this range of the stop screw, if for some reason it does not come in within range, your throttle position sensor is considered bad at this point. For test 2, we need our resistance to be less than 2.3 kilo ohms or 2,300 ohms. Right there we have about 20 ohms of resistance with very minimal movement of that throttle position sensor. Now we are going to secure that screw again and hold that position and start all over at step 1 to make sure step 1 is still within range now. Removing your feeler gauge from the throttle stop screw and now repositioning your terminal back up to the VTA E2 terminal combo, you're going to see our meter is either going to come in range or not. And right now for step 1, our spec was between 200 and 800 ohms. Previously we were reading about 550 ohms, but with just that slight adjustment to bring step 2 into range, you can now see our step 1 changed with resistance down to about 428, 430 ohms range, which is still within our range of 200 to 800. Once you have reconfirmed step 1, step 2 was confirmed already as well, but you can always double check or triple check your work just to make sure you have a good reading on step 2 with your feeler gauge reinserted back in the idle stop screw linkage location. We can reconfirm our test 2 is less than 2,300 ohms. Continuing on, we are going to keep the leads in those same terminals for step 3, but we are going to switch out our feeler gauge for the 0.0335. With step 3 of the test, we hopefully should get an OL or open reading on our meter.
And there it is.
There we go. So step 1, 2, and 3 have been confirmed and are in good range. Therefore, I consider this TPS has now been adjusted properly. Now that we performed all 3 steps to get this TPS within range, we are going to set both screws, making sure at least the one we did tighten up that was easy to access on top is solid, and then reconfirming the bottom screw, tightening it up firmly, making sure it's going to hold our throttle position sensor in the right location. These are little screws, so do not over torque or strip them.
Okay, now we're just gonna reconnect the throttle body. Since you took it off, you know how it goes back on. We're not gonna waste time showing it. We disconnected the throttle body from the plenum, but to be able to show you in greater detail the procedures to adjusting the throttle body stop screw and to go through the procedure of testing the throttle position sensor and adjusting it, we now have another throttle body on the bench to show you the procedure.
Some folks may have had their throttle body tampered with previously, and so to set your idle adjustment stop screw, we are going to loosen up the 8mm nut on the other side of this adjustment for the linkage. Just a half turn should loosen up that enough, and we are going to completely back off the screw.
Looks like the Allen head is a 2.5 for this adjustment.
You'll first back off the adjustment screw until you see air gap in between the actual throttle linkage and the stop screw. Once you get a little air gap between the throttle linkage and the stop screw, you're going to adjust it into where it contacts and then go another quarter turn so that it can actually separate from where the actual throttle plate would start cutting into the aluminum throttle body.
So basically what this adjustment's doing is it's stopping the ability of the throttle plate getting stuck into the bore of the throttle body. So you want it to where there's just a little bit of tension on this to where it can't turn in there and just wedge itself into there.
To set the throttle stop screw, you're going to want to hold the adjustment screw with the Allen as you're tightening your 8mm nut at the base to make sure that your adjustment doesn't move as you're tensioning this lock nut.
If you found that it was too difficult to do the tests, just like we showed you, leaving the throttle body in the engine compartment with the coolant hose is still attached, we're now going to show you the same steps if you actually pulled your throttle body off the engine and now you have it on a bench with a lot more accessibility to perform all the steps with the feeler gauge and with your ohm meter.
So with our leads hooked up to terminals VTA and E2, we are going to have no feeler gauge at our stop screw. We should get a reading between 200 and 800 ohms for 85 to 88 models, and 470 ohms to 6100 ohms on 89 to 95 models. This, reading 658 ohms, is within range. In step 2, we are going to put our terminal leads into idle or IDL and E2 terminals, the third and fourth terminal from the top to bottom. We are going to take our feeler gauge and lay it right in between our throttle stop screw and the throttle linkage. With our meter reset, we have an OL reading, which means out of limits or infinite. That is a failed test in step 2.
And that's what I had on mine too, right?
Exactly.
So this throttle body that we have on the bench failed the second test just like mine did.
Very carefully with our Phillips screwdriver, firmly loosening up these screws, just a hair. Now we should be able to have free play. If I loosen up that other one again a little bit more, we should be able to shift our throttle position sensor within those slots. In step 2, our reading has to be less than 2,300 ohms. We are going to shift this around until we can find less than 2,300 ohms. And in this case, it took quite an adjustment to get into range. We are almost at the end of our adjustment. So as long as it has any kind of reading that is less than 2,300 ohms, we are going to tighten our set screw to temporarily lock in our TPS so it doesn't move while we recheck step 1 again. Moving back to step 1.
So again, step 1, you have the terminals at the second from the top and the fourth from the top.
And with no feeler gauge installed. Our reading shows 394 ohms, which is still in range for step 1. Knowing step 2 is happy and healthy with our previous adjustment, we are going to jump to step 3 and just verify with a .0335 feeler gauge in between the throttle stop screw and the throttle linkage. As you can see now, we still have a reading of 37 ohms when it should be an infinite or open reading. We may need to come in here and adjust again to see if we can get our throttle position sensor within range of those first 3 steps. There it is OL, and with the tiniest movement, I'm going to go back and forth until I feel I'm right on the edge of that open limit in the sensor's position. And at this point, I still like to go through all 3 steps again to make sure that my resistance values are all correct with each step. So terminals 2 and 4 with no feeler gauge installed, we are at 476 ohms, which is correct for our range. And step 2, reconfirmed at the idle and E2 terminals with our .0224 feeler gauge installed carefully. You can see we are less than 2,300 ohms. And knowing that step 3 with our feeler gauge inserted does give us the open or infinite reading, we know our TPS is correctly adjusted now.
We hope that was clear as mud to you. Those are the steps you want to do to check and adjust your throttle position sensor on your 22RE motor. How do you like my hair? All right, we're all done with this job. I think Mike did an excellent job of describing the steps to test and adjust the throttle position sensor on a 22RE motor. It's not really that difficult. You just have to have a multimeter that reads ohms resistance, and you go through the 3 tests that Mike showed you, and you do the proper adjustments if you find at one of the testing steps that something is out of adjustment. Then I suggest you do what Mike says, and once you make the final adjustments, go through all 3 tests again, making sure that they all 3 pass. With all that said, we thank you for watching Toy at a Time with Timmy the Toolman and Sean, and special guest Mike at Yoda One Performance. Thank you for watching. Thank you for subscribing. If you have any questions or comments, do that below. Take care. Bye-bye. Sick mods and happy wrenching, people. Peace out and bye-bye. Happy TPS.